Hello everyone. So let's continue our small project here of measurement of resistances. So we already calculated RAB. Let's do calculation for RAC. Okay, so the resistance between terminals A and C. So I'll just begin by again verifying the value. So just I want to measure it once again. Fair enough, we are getting 165 kilo ohms. So that's what I have written it under the measured quantities. Now let's calculate it and try to match it. So how do we calculate? So let me go to the next page, RAC calculation. So for calculation of resistance between A and C. So again, this is our circuit, and how do we calculate? So RAC. Now right away you can see my points of interest is between A and C. So therefore this 68 and 100 will become series connected, which is in turn connected in parallel with 560, which is again in turn connected in parallel with 820. So the more practice you do, you can just visually work out this thing. So let me directly from this main circuit, let me directly go to the next level circuit, that is simplified version of circuit. So this is 220k as it is. So I get B here, and from here I will directly combine 100 plus 68. I'll directly show it as 168 kilo ohms. Then I have one more connection here, that is 560 kilo ohms. Then I get point C here. D point right now it's all eliminated. So then I have this 820 kilo ohms, and then I have 330 as the overall branch. Okay, so here these three are in parallel. 330 is not in parallel with this, because these three are in parallel, then they are series with this, and then there is a parallel connection with this. So again, our interest is RAC, between A and C. So how do we calculate the parallel of all three? So we can do parallel of 2, and then again in turn we can do parallel of other. So of course there is a direct formula, but let's do it step by step. Now in the previous problem we had calculated for the case of RAB, the parallel combination of 560 and 820 we already calculated here. Okay, so if you take this BC point, this 560 and 820 were already parallel, so 332.75 that value. So I'll just take it here for ease. So A 220k, and I have B here. So 168 is as it is, kilo ohms, and here the parallel combination of 560 and 820, that was 560 multiplied by 820 divided by 560 plus 820, 332.75. So 332.75k. In fact, we also did this combination also. So let's go back to that. So 330 kilo ohms. Now in the next step, now I will do the parallel combination of 168 with 332.75, which was also done in the previous video. So we got 111.64. So again, instead of using calculator, I will directly do this. So what is the calculation? 168 multiplied by 332.75 divided by the sum of 168 plus. So here is a formula, RA RB by RA plus RB. So okay, so for this I'll get 111.64 again. So I'll do that here again. 220 kilo, this point B, and this is the resistance 111.64 kilo ohm, and I get point C, and here I have 330 kilo ohm. Now I am interested in resistance between A and C. Okay, so because I am interested between resistance of A and C, these two will become series connected. In the earlier case, I was interested between resistance of AB. In that case, this and this became series. The 111 and 330 became series connected. But in this case, I am interested in between A and C. So this is one branch and this is one branch. So let's now simplify further. So I'll get 220 plus 111.64. It will be something like 331.64 kilo ohm, and that is in parallel with 330 kilo ohm. Now this is C and this is A. So therefore, finally I'll get RAC from this. So let's calculate that. So I'll just get in my calculator. So in order to calculate RAC, I just multiply these two and then divide by the sum of these two. So first 331.64 multiplied by 330 and then divided by 331.64 plus 330. So I'm getting 165.4 kilo ohm. So this is the calculated equivalent resistance between the terminals A and C. And if you see at the beginning of the video, we measured it and the value was 165. So the calculated value is 164 kilo ohm. I'm sorry, 164 point, what was that? 165.4. 165.4 kilo ohm. And again, how do we find the error? We use this as the reference and then we calculate the error out of that. So 165 divided by 165.4. Okay, so the error is this much. So if I subtract from 1 and if I want to express it as a percentage, so it is minus 0. I have to multiply with 100, so 24%. So again, the error is less than 1%. So as long as the error is less than 1%, it is fine. We design these circuits such a way they can handle the errors of even 5% error also it can handle. So but then here in our case, error is less than 0.5% in fact. Okay, so let's in the next video let's go to the resistance AD. In fact, I'm sorry, we'll not do AD because AD has a small problem. We have to do delta to star conversion. We'll come to it, but before we go to AD, let's directly jump to RBC and we'll do that. Okay, so let's go to RBC in the next circuit, in the next video, that is. If you find this video interesting, please do like and subscribe to my channel. See you in the next video. Thank you.